Hello, my wonderful topic students. This is going to be part one of I don't know how many parts of our prime factorization and order of operations flipped classroom workshop today. The first thing you want to do is take a moment and update your table of contents. So, last class, some of you may have started to see and you wrote down that page 16, or it could be a different page in your notebook if yours is a little bit, the numbers are a little bit off. The page after where we're going to put our exponent homework 1E, is going to be where we do our warm up and workshop notes for order of operations and prime factorization. This workshop is going to kind of take us to page 17. So for page 17, you could just put continued from page 16, or you can just duplicate. You can write order of operations, comma, prime factorization twice. So page 16 and 17 are what our workshops are going to cover today, and they're going to cover the topics of order of operations and prime factorizations. So you can take a moment to pause the video right now, so that way you can get your table of contents updated. And then once you have your table of contents updated, you can hit play again. So that way we can get started with this workshop. Okay, so on the top of page 16 of your notebook, okay, you can title this page Prime Factorization. Now, your warm up from when you came in is probably up here in this top section. So, wherever you ended this warm up, go ahead and just draw a line to section out kind of where your warm up ends / where your workshop notes are going to start. Okay. So the first thing we're going to talk about is we're going to talk about prime numbers and this special cool thing in math called prime factorization. Okay. So the first thing we're going to do is we're going to define what a prime number is. So I'm going to write prime numbers. Okay. And prime numbers, as I'm sure many of you know, are positive integers that are greater than 1 that have exactly 2 factors. And those factors are 1 and the number itself. So what I just said, that is going to be the definition we write. So prime numbers, a positive integer that's greater than 1. I'm going to use the symbol greater than. You could write out the words greater than if you want. A positive integer greater than 1 that has exactly 2 factors. And then I'm going to put a dot, dot, dot. The 2 factors are 1 and the number itself. So 1 and the number itself. So if we look at some examples, I'm going to switch colors here. You don't have to. Let's say we have the number 2. The number 2 is a prime number. It is a positive integer, and the only 2 factors that we can use when we multiply them together to make 2 are 2 times 1. Another example would be 5. 5's factors are 5 and 1. Another example would be 19. The only factors of 19 are 19 and 1. So there are a lot of prime numbers. Most of them tend to be odd. 2 is an even number, and it is a prime number. Okay, so prime numbers are numbers that only have 2 factors, the number 1 and itself. Okay, now prime numbers are not the only kinds of numbers that we have. The opposite of a prime number is what's called a composite number. We're not going to write down that definition, but a composite number is a number that is not prime. It is a number that has factors other than the number itself and 1. So an example of a composite number would be 6. 6 is a composite number because we can take 6 times 1. Those are 2 factors of 6. But we could also multiply 2 times 3 to make 6. So 6 is not a prime number. It's a composite number because it has factors other than 6 and the number 1. There is something special in math, and it's kind of a fancy name and it's kind of a fancy definition, but it'll make more sense in a moment. It is called the fundamental theorem of arithmetic.